Welcome to Ask and Learn.
All right, so for this problem, we want to prove that f is big theta of g of x if and only if there are constants k, c1, and c2 such that c1 times the absolute value of g of x is less than or equal to the absolute value of f of x is less than or equal to the absolute value of c2 times the absolute value of g of x whenever x is greater than k. Okay, so we'll start with, say, going from the first part to the second. So what that means is we're going to assume that f of x is big theta of x and show that there are constants k, c1, and c2 such that this inequality holds. Right, so here we assume that f of x is big theta of g of x. Okay, well, so by the definition of big theta, this implies that f of x is big O of g of x, and f of x is big omega of g of x. Okay, so by the definition of big O notation, then there exists some constant c2 and k2, right? So we'll say that since f of x is big O of g of x, then we know that there are these constants c2 and k2 such that the absolute value of f of x is less than or equal to c2 times the absolute value of g of x whenever x is greater than k2. And by the definition of big omega, then we have similarly, so I'll write this out, since f of x is big omega of g of x, then we know that there must be these constants c1 and k1 such that the absolute value of f of x is greater than or equal to c1 times the absolute value of g of x when x is greater than k1. So then we're going to say, well, let k be the maximum of k1 and k2. And then we can combine these two inequalities. I kind of run out of room, so I'm going to do it on the next page here. And so that's going to be that c1 times the absolute value of g of x is less than or equal to the absolute value of f of x is less than or equal to c2 times the absolute value of g of x when x is greater than k, which was the maximum of our k1 and k2. All right, so therefore we've shown that there exist constants k, c1, and c2 such that this inequality holds. So we've proven, so from the left to the right case is now proven. And then we want to consider case 2. In this case, we're going to assume that there exists constants. So I'll write that out. So we're going to assume that there are these constants k, c1, and c2 such that C1 times the absolute value of g of x is less than or equal to the absolute value of f of x is less than or equal to C2 times the absolute value of g of x. And now we want to prove that f of x is big theta. Of course, this is going to be when x is greater than k. Well, then we know from the inequalities above, we can just infer that the absolute value of f of x is less than or equal to C2 of the absolute value of g of x. Right, that's just this little chunk here. When x is greater than k. So by the definition of big O notation, this implies that f of x is going to be big O of g of x. Great. Well, we also know from the inequalities, we can do the same thing. We're going to take this little left chunk, right? We're going to say, well, we also know then that the absolute value of f of x is greater than or equal to C1 times the absolute value of g of x. And of course, this is going to be as well when x is greater than k. Well, this is the definition of big omega notation. So then we can infer that f of x is big omega g of x. All right, well, so if we have that f of x is big O and that f of x is big omega, then this combined implies that f of x is going to be big theta g of x. This way was a little simpler, I think. And that will conclude the proof.